Good morning, class. Before we begin today's class, from this point on, while you're at home, we're no longer going to be opening the attendance form. Many students are uploading their homework, and being students, they forget to just type here. I know it's incredibly complex and difficult, but students forget. So what we're going to do is we're just going to leave the basic class answer question in video form and the homework. You upload your homework and that counts as your attendance. Do not miss a single day. If you lose a single day, that's about 10 points less off your notebook for a single day. There's going to be multiple grades. Make sure you send everything. Again, from now on, the homework will be your attendance. I hope that's clear. So today we're going to go over 5.2. 5.2 is pretty much the properties of rational exponents. Now, it is critical that you learn these properties just as you need to learn factoring. Remember, I told you at the beginning of the year, guys, you're going to be using factoring the entire year. You're also going to be using this a lot from now on and also next year. So again, make sure you learn it properly today, or you're going to have problems. Because when we mix factoring with these properties, you're going to go crazy. Make sure you learn these properties well today. Now today, we are only going to focus on the exponents. On Monday, we're going to focus on radicals. Because remember, yesterday, we turned fractional exponents to radicals and vice versa. Don't worry, that's not Corona. You're not that lucky. And so yesterday we were converting radicals to exponents and vice versa. And we're going to practice that a little bit more on Monday. But today, let's look at the properties of just normal exponents. But note that this chapter is going to be dealing mostly with some sort of fractional exponent. Because again, as we saw yesterday, if I have, say, for example, this expression, I'm usually going to turn this into a base 8 and a rational exponent. So then I can use these exponent rules. So again, make sure you know how to convert radicals to exponents that we did yesterday. Again, the power of the number on the radical goes to the denominator. The number that's the exponent goes to the numerator. The way I learned it is, the number that is slightly in the bottom goes to the bottom. The number that's on the top goes to the top. Very simple way to learn this. And again, we're mostly going to be converting this to this and then using these rules in order to work. Not all the time, but most of the time. So again, let's look at the first rule, which is called, all this is on page 244 in the core concepts. So let's go over the product of powers. Again, the product, which is the result or the multiplication of powers. If you have the same base, I repeat, if you have the same base and you're multiplying the base, all you have to do is add the exponents. X to the 3 times x to the 4 is x to the 7. It is not x to the 12. Note the x doesn't change. You just put the same base and you add the exponents. If I have 7 squared times 7 to the 5th power, that's just the exact same base. You don't multiply the base or anything. 7 to the power 10. That is the first rule. Also note that you could also be multiplying fractions. X to the 1/3 times x to the 2/7. When you multiply fractions, same base, you multiply numerator times numerator, 2, denominator times denominator, 21. Done. And then again, just for practice, if I want to turn this into a radical, 21 root of x to the 2nd power. Make sure you practice converting it to and from exponents and radicals. We will be using that a lot. So that takes care of the first rule, the product of powers. Now, when we do the power of a power, when you raise an exponent to another exponent, that's where you multiply. For example, a3 to the 3, that is actually a to the 9. You multiply. Here you don't add. Again, when we multiply, we add. When we raise to a power, you multiply. And if we were to break it down, would a3 cubed not be a3 times a3 times a3? That number times itself this many times. And now if I apply the rule of the multiplication or the product, and I add all my exponents, I end up with a to the power 9. So, power of a power, you multiply. Exact same thing applies to fractions. X to the 1/3 to the 3/4. You multiply this times this. Numerator times numerator gives you 3. Denominator times denominator gives you 12. You simplify x to the 1/4. And you're done. And again, if you want to turn that into a radical, quartic root of x to the first power. Normally, you don't put a first power, but I want you guys to see it. So again, if you plug this into your calculator or do this, it's going to be the exact same result. So power of a power, you multiply. And I repeat, you need to know these rules at 200%. Because this is very tricky. When we get back to school, the tests of this subject are going to be very, very long and very complex. Believe me. Practice. Use this time you have at home to practice. Now here, when we have power of a product, again, product, a multiplication, exponent, power of a product, you just distribute the exponent. So say, for example, let's look at 2 examples. Say I have 16 to the 2nd power. In some cases, you'll see, and again, this doesn't have to be ours, but I want you to visualize. Is 16 not 4 times 4? And if you were to use this rule, this would be the exact same thing as distributing the exponent to every element. So you can do that. You can break a number into factors and then distribute. And also, this is another trick. And again, if you have different bases, but the same exponent, so we're working backwards, you could actually multiply these two and then raise it to the exact same power. It's the same thing as distributing back. So when you have numbers, again, if you have a whole number, you can break it into factors and distribute the exponents. If you have 2 different numbers with the same exponent, you can multiply the numbers and get back to the original number. And also, if you have letters or a number and multiple letters, that's fine. This is the same thing as x squared, y squared. This is the same thing as 7 cubed, x cubed, y cubed, z cubed. So pretty much the power of a product, it's just using the distributive property, so to speak, and distributing your exponent into every element within the parentheses. Okay. Now, here is one particular rule that for some reason students struggle with, and you'll see that once you practice it, it's not that difficult. Yesterday, while you were doing the homework, many students said, Profe, but there's one that's got a negative exponent for some reason. What the heck do I do? Now, for some reason, the book doesn't give this class first. I don't know why. But the problem is, let's say you have a negative exponent. That is the same thing as finding, como quien dice, el inverse. So you can flip it and send it down and change the sign. Right now, every number has a denominator 1 if I'm not writing any. So if this number right now has a denominator of 1 because you can't see it. Oh, 1, sorry. Oops. math teacher here. So what you can do is send this number to the denominator, the one that has a negative exponent, and turn it positive. At the same time, if you have a number in the denominator with a negative exponent, you can send it to the numerator in a positive fashion. So basically, interchanging it from the numerator to the denominator changes its sign. And it's just the sign of the exponent, not the sign of the coefficient. For example, let's say I have 16x to the negative 2y over x squared. I have this number. I have this expression. This variable and only the x that has a negative 2 will be sent down here in a positive fashion. And now I can multiply these two bases, which are the same. And when you multiply the bases, you add the exponents and you're left with this expression. And that's pretty much it. Likewise, if you have a parentheses, the entire parentheses gets sent downward with the sound change to the denominator. So that would turn into this. So flipping it between the denominator and the numerator changes the sign of the exponent. I hope that's clear. So every time, and also you always want to work with positive exponents. It's not a requirement, but it's going to help you think in a more clear fashion. So anytime you see a negative exponent, just send it to the, if it's in the numerator, send it to the denominator. If it's in the denominator, send it to the numerator. Always work with positive exponents if possible. Now, let's go over the rule, the quotient of powers. When you have the same base and you divide, it's the exact same thing as subtracting these two. Now, let's see if it's true. Let's say I have x cubed minus x squared. Normally, if you were to simplify, you could just say, I take 2 away from here and I'm left with x. That's one way to simplify. Another way to simplify is to break the numerator into x squared times x. In the bottom, you have x squared. You simplify, and again, you're left with your x. This property pretty much does the exact same thing. If I have x squared, x cubed, and x squared, and I subtract, I'm left with what? Just x to the first power. So when you have the same base, you can subtract. Now let's look at a couple of examples. Let's say I have x to the 4, and under here I have x to the negative 2. Let's use two rules. First, let's use this rule, the rule of the quotient of powers. So I'm going to have x4 minus my denominator, or the exponent of my denominator, which is negative 2. And what is minus negative 2? It turns positive. And I'm left with x to the 6th power. Okay. Now let's use this rule to solve. The exact same one. It's a negative exponent. I want to turn it into a positive exponent. So I move it to my numerator as x squared. And the product of powers, you add the exponents, you're left with the exact same answer. Again, you can do it either way, but I recommend you just flip it up here and work with positive numbers. That avoids the sign changes, negative times negative, positive times negative, and sometimes students get confused. So that's an example of the quotient of powers. So again, 6 to the 17 over 6 to the 13. 17 minus 13 equals 4. That's the exact same thing as 6 to the 4. Bien. I hope that's clear. Now the final one, the final property, is pretty much similar to the distributive in the multiplication, only it's the distributive with the division. So if I have 6 over 5 to the second power, that's the exact same thing as 6 to the second power over 5 to the second power. If I have xy over 3 to the second power, this is going to be x to the second power, y to the second power over 3 to the second power. Remember, the square applies to all terms, not just y or something for some reason. You just distribute it properly. So those are the basic rules which you need to really manage properly so you don't have trouble with the remainder of the year and a lot of next year. Again, I'm giving you the same warning I gave you guys with factoring. Make sure you know these rules properly. You will use them frequently. Make sure you know them. Now let's go over the examples that they're giving me in example 1. Again, let's go over example A. This is page 244. So they gave me 7 to the 1/4 times 7 to the 1/2. Again, the same base that's being multiplied. When you multiply, you have to add the exponents. Oh my God, why did it have to be fractions? Save me. Add fractions. You should be able to add fractions. 1/4 plus 1/2. You multiply this side by 2. This gives you 1/4 plus 2/4. When you add with the same denominator, the denominator stays the same. And you do the operation with the numerators. That gives you 7 to the 3/4. And again, if you want to turn that into radical form, that is 4th root of 7 elevated to the 3rd power. Not necessary. I recommend you practice. So that takes care of example 1, multiplying numbers with fractional exponents. Let's look at example 2. 6 to the 1/2 times 4 to the 1/3 to the second power. Now here, all you're going to do is distribute the 2. So this is going to become 6, 2 over 2 times 4, 2 over 3. This simplifies down into 1, and you're left with 6 times 4 to the 2/3. Done. All I did was distribute the 2. That's all you have to do. Again, Profe, what do I do here? You can't do anything. For you to do something here, either the bases have to be the same or the exponents have to be the same. Since you're not getting either case, you just leave it like that. There's nothing you can do. Again, to be able to multiply these two properly, because again, you can just plug that into a calculator, done, you can multiply. But the whole point is working without using calculators. The numbers have to be the same or the exponents have to be the same. Right now, you just leave it like that. You do not have to plug that into your calculator or anything. That was example B. Now let's go over example C. 4/5 times 3/5 times, or that is elevated to the -1/5. Okay. Now, negative exponent, the first thing we do is turn it positive. 4/5 times 3/5 to the 1/5. Now, there are two ways you can work. I recommend you get rid of the exponent first. So I'm going to multiply 5 times 1/5 goes away, and 5 times 1, doesn't go away, it becomes a 1. So it disappears, but there's a 1 there. So 5 times 1/5 is 1, and 5 times 1/5 is 1. So I'm left with 4 to the first power times 3 to the first power. And 4 times 3 is 12. Okay. So again, anytime you see a negative exponent, turn it positive, then work. The other way you could have done this was combine these two and turn it into a 12 to the 5th power. And when you multiply that to the 1/5, you'd get the exact same answer, 1/12. but I recommend you distribute first. That takes care of example C. Now let's do example D. 5 to the 5 1/3. Okay. Same base. The exponent here, when you don't see a number, remember it's 1. Since it's a division of numbers of the same base, you subtract the exponents. 1 minus 1/3 multiplied by 3, multiplied by 3. I'm left with 3 over 3 minus 1/3. Same denominator, doesn't change. Operations with the numerators, 2/3. So this will be the exact same thing as 5 to the 2/3. And for my final example, I'm going to do E. I have 42 to the 1/3 over 6 to the 1/3. And this is squared. Wow, prof, I got fractions within fractions and exponents and I'm going crazy. That's why you have to practice. It gets way trickier. You're going to have some problems, a single problem that might be just this board full of parentheses, fractions, and exponents. You have to know how to work this. Now, there are multiple ways to work this. What I recommend is, again, please remember, you can't just subtract 1/3 by 1/3 because the numbers aren't the same. But in this case, I have the same exponents. So what I'm going to do is, I'm going to do 42 over 6, and that's elevated to the 1/3, and this is elevated to the square, to the second power. So I did this rule. I went from this expression, a number to an exponent, and a different number to the same exponent, to this expression. And why do I do that? Because now I can divide. What is 42 divided by 6? 7 to the 1/3, and this is elevated to the second power. Now, power of a power, you multiply, and you're left with 7 to the 2/3. Again, you need to practice. That's it for today's class. Now, for the exercises, I want you guys to do from page 244. Let me erase this. This is the homework. From page 244, do numbers 1 through 4. And from the exercises, do 3 through 12. Remember, no attendance, upload the homework, that will be your attendance. Do not miss a single homework. It's gonna heavily impact your grade. Don't just think, oh, it's just a single homework and I got 20. No, you miss a homework, I'm gonna drop 20 points off your notebook for a single homework. Do not miss a single day. If it's 9 p.m. and you're having internet trouble, you let me know at 9 p.m. or beforehand. Don't wait until the last time and write me at 10:30 at night. Oh, prof, I couldn't upload my homework. Okay, make sure you work. Make sure you practice. Have a great day. I'll see you guys soon.